Very good morning, children. This is your physics teacher Sharma. I'm safe and healthy at home. I hope you are also staying home and staying safe in your houses. Okay, now today let us discuss about the topic force and pressure. As we are having two classes for this week according to the schedule, we will be completing this chapter in two parts. In today's part, we will be discussing about force, wherein we will learn what force is and how we define it. We will be discussing that force is because of an interaction between two or more bodies. We will be learning what resultant force is and what are the effects of force. Also, we will be learning about two different types of forces, which are contact force and non-contact force. First of all, let us try to define what force is. Actually, any object, if you want to move from one place to another place, what do? We put our hand over that and we try to push it, right? So if I want to push or help someone who is having their car broke down in the middle, they ask us for help and they ask us to push. So what we do? We push it. So we are exerting force away from us to make it move forward, right? So that is called a push. In the same way, suppose we see small children playing with a toy car, wherein there is a long rope. They hold the rope, one end of the rope with their finger, and the other end of the rope is tied to a toy car, and they pull it. They move it, so it moves. It follows the child. So in this case, we see it is being pulled. We can also see this in case of cycle rickshaws. So rickshaw puller is actually pulling the rickshaw. You see, the person who is exerting force is in front of the object or in front of the object on which force is exerting. Then we say it is pulling. And if the person or the agent which is exerting force is behind the object, then we say it is pushing. So in simple, we can say force is nothing but a push or a pull. So force is nothing but a push or a pull acting on a body. Now when we say it is acting on the body, definitely there is some interaction between these two. There is some connection between the object on which the force is acting and the object which is exerting force. Okay, for example, say we are playing cricket, okay, and someone bowls at me and I try to hit the ball with my bat. Then what am I actually doing? I'm hitting, I'm changing the direction of the ball, I'm changing the speed of the ball. Okay, in simple, I am exerting, I'm pushing the ball away from me. Okay, when I'm saying I'm pushing the ball away from me, with no second thoughts, it is a force that is acting on the ball. Okay, now that pushing the ball away from me is happening only after the ball strikes the bat, isn't it? It is not a magic wand wherein I show the bat and the ball moves away, isn't it? So there is some interaction. They come in contact with each other, they interact and then they move. So let us say there is a game of tug of war between two groups of people. So there also again we see they are pulling each other by means of a rope, of course. Okay, so always for the force to exert, there should be some interaction. There should be a body which is exerting force and another body on which the force is acting. Okay, now let us consider an object which is like this. Okay, now on this object a force of 2 Newton is acting towards the right side, and there is another force which is acting towards the left side, and let us assume that force is also 2 Newton. So definitely the total force acting is 4 Newton. We can see that. Okay, we can clearly see 4 Newton force acting on it. But if you notice, these two forces are acting in opposite direction. Okay, because forces are acting in opposite direction, what do? We subtract. Okay, so total force acting is equal to 2 minus 2, that is equal to 0 Newton. Now let us consider another case wherein there is an object on which 2 Newton force is acting, another 2 Newton force is acting, and these two are acting towards the right side, and a force of 5 Newton is acting towards the left side. Now what will be the total force acting? For this, let us calculate separately the force that is acting towards the left side and the force acting towards the right side. Now let us first calculate the force that is acting towards the right side. Okay, F towards right. So both forces are acting towards right side, towards the same direction. So what do? We add these two forces. So total force would be 2 plus 2, that is equal to 4 Newton. Now what about the force that is acting towards the left? It's only one force, that is 5 Newton. Now what is the total force that is acting? Total force, which I can otherwise call it as resultant force. Okay, it is the difference between these two forces because these two are acting in opposite directions. So it would be 5 minus 4, that is equal to 1 Newton. This 1 Newton towards left side. Okay, so this is how we are calculating the resultant force acting on an object. Now coming to the next one, that is contact and non-contact force. Already we have just now learnt that for the force to act there should be some interaction, right? Now is it that always these forces which are interacting should be in touch with each other? Actually not. We are having two types of forces. One is contact force, the other one is non-contact force. Okay, what is the meaning of this word contact force? The name itself says contact, it is touching. Okay, if I want to move a suitcase or a box towards me or away from me, excuse me, whether it is towards me or away from me, what I should do? I am not a person who is having this mystic magical power wherein I show my finger and the box moves away, right? So I need to touch the box and I have to push it away. So automatically my hand, which is exerting force, is in contact with the box on which the force is acting, isn't it? So this kind of force wherein the agent which is exerting force is in contact with the object on which the force is acting is called contact force. Okay, example for contact force is muscular force. Okay, so muscles which we build up by taking a high amount of protein input. Okay, so by the help of this muscular force we are able to do any work. For example, yes, as I said, we push or pull, we are doing work. Similarly, horse pull a cart, a bull pulls a cart in a bullock cart. So all these places, in all these cases, we see these animals, and of course we are also using our muscle power. Okay, so this force which is exerted by any living organism because of their muscle is called muscular force. Now the second type of force is friction. How do we define friction? Friction is a force that acts between two bodies which are in contact with each other and does not allow one body to slide over the other. Okay, so friction is a force, friction is a contact force for that matter, to be more accurate. Friction is a contact force which opposes relative motion of two bodies. Okay, it does not allow one body to move over the other body. Okay, so that is friction. Now this friction is again classified into different types which you will be learning in your second chapter. Okay, now coming to non-contact force. Yes, again, is it possible that the body which is exerting force does not come in contact with the body on which force is acting, but the effect is seen? How is it possible? Like, are there any cases? In fact, yes. For example, if we take magnets, a magnet will attract a piece of iron. It is not that, let us assume, this marker in my hand is a magnet, and let us assume this is a piece of iron. Now, when I bring this close to the piece of iron, we immediately see these two attracting. It is not that I have to bring the magnet in contact with each other, only then they move together, isn't it? So what is happening? We can clearly see that even though they are not directly in contact with each other, the effect of the magnet is there on the piece of iron. So these kind of forces wherein, in spite of the two objects, the one which is exerting force and the one which is on which the force is acting, are not in contact with each other also, okay, the effect can be felt. Those are called non-contact forces. Okay, there are three examples explained for these non-contact forces. The first one, magnetic, which we have discussed just now. Second one, electrostatic. Okay, this electrostatic is another important as well as interesting topic in physics, wherein we see this every day. Like, you might have come across the experiment or an activity wherein you take a balloon, you rub it, you blow air into it, you rub it against your dry hair, and that starts attracting small pieces of paper. The same thing actually happens with your plastic scale as well as your comb. But with a rubber balloon, you can experience it more easily. Okay, so where there is an exchange of charge because of rubbing against your hair, there is friction, and that results in the exchange of charge. Because of the charge only, we are using the word electro. Okay, so it starts attracting pieces of paper. So this is electrostatic force. And a third one is something which we are very familiar with, that is gravity. So if I drop an object which is falling down, why is it falling down? Because the earth is pulling it towards itself. Okay, the earth is pulling the object towards its center. So that force with which the earth attracts any body around it towards itself is called gravity. And if you have noticed, in all these three cases, magnetic, electrostatic and gravity, the object which is exerting force is not in contact with the other body, but it is still able to attract. Okay, so in this way, these three are standing as a good example for non-contact forces. So we'll call this a day for today for science, for physical science to be more precise. And I suggest you to read all the activities which are there in the textbook for this. And subsequently, I'll be giving you notes in form of PDF, which you can write it down either in your papers or if you have a notebook in that. then you can paste it in your notebook, which will be convenient for us. Okay, like have a nice day. Bye bye.